Okay, ladies and gentlemen, let's go ahead and take a look at proving trig identities. Basically, what we've got right here are identities, and the steps that we want to use are these. We talked about this a little bit in class today. It says choose a side to work with, and usually you're going to choose your more complicated side. As we take a look at this identity right here, cosine is very simple. Obviously, it's just a simple trig function. Sine over tangent is a little bit more complicated or complex. I'll just put complex here because that's shorter. And so we're going to work with this side right here. And basically what we want to do is we want to, step 2, use algebra to make the complicated side, this side, look like the simple side, this side. Real important here, never touch or change the simpler side. The simpler side is going to simply come straight down. So let's give this problem a try. We're going to work with this side right here. What can we do with this side? Well, we talked about in class that there are basically a number of different strategies. One, convert everything into sines and cosines. Another possibility, use your identities from our purple identity sheet, and you may need to rearrange those identities. The third strategy, you may want to use FOIL if it's a binomial times a binomial. You may want to factor. You may want to choose your distributive property. If you see fractions, you may need to use rules of fractions. So, all those different things that you learned years ago are going to be helpful here. Let's go ahead and take a look at this first problem. Obviously, we have tangent here. Let's go ahead and convert that into sines and cosines. We'll keep the sign on top the same. In fact, I'm going to just write this as sine over 1 because I know my tangent is going to be a fraction in just a moment. And we know the tangent's going to become sine over cosine. The right side, cosine, comes straight down. Next, as we take a look, we have a fraction divided by a fraction. Well, anytime you have a fraction divided by a fraction, instead of dividing, you can multiply by the reciprocal. So let's take the numerator and multiply by the reciprocal of the denominator. When we do that, we're going to end up getting sine x over 1 times, and when we take the reciprocal here, we get cosine over sine. The right side stays the same. Again, you never touch or change that simpler side. What happens next? Well, now we've got a couple of fractions that are being multiplied. And anytime that you have fractions being multiplied, you can simplify or cancel first. The signs become 1s. And so what are we left with? On the left side, all we have here is 1 times cosine, which is cosine on the top, 1 times 1, which is 1 on the bottom. Cosine divided by 1 is just going to be cosine. So the left side becomes cosine all by itself. The right side, well, that was already simply a cosine. So this checks, it works right out. I want you to go ahead and try the next one similarly. So pause the video, try it, and then we'll go through it. Okay, let's go ahead and take a look at the next one and see what we can do. Again, we want to work with a more complicated side. I'd say this side is more complicated. And so let's see what we could do. Changing everything to sines and cosines is not going to help here because we already have cosines. However, this you may recognize as being part of one of our identities. We know that we have a 1 and also a cosine squared in this identity on our purple formula sheet. Sine squared plus cosine squared equals 1. And let's go ahead and manipulate this identity so that the right side looks exactly like this. So we have a 1, which is the same as this one. I need a minus cosine squared on this side, so I'm going to go minus cosine squared. But we know the rule, whatever we do on the right side, we do on the left side, so I got to do a minus cosine squared there. And when we look at this, we realize that 1 minus cosine squared is actually the same thing as sine squared. So the numerator can be replaced by sine squared. Let's go ahead and do just that. So the top right here becomes a sine squared. The denominator, cosine squared. And the right side stays the same. Next, well, if we have sine squared over cosine squared, we could write this as sine over cosine, where the whole fraction is squared, because that is the same thing here. Oops, sorry about that. That's the same thing as this. Think about it. If you score sine, you're going to get that. If you score the cosine, you're going to get that. However, sine over cosine, according to our formula sheet, is tan. So we get tan squared equals our tan squared. And that checks right out. Okay. I want you to copy down and try the next one here on the left side. And then we'll go through that next one. So pause the video, give that a try, please. Okay, let's take a look at this next one. It's sort of hard to figure out which side is more complicated, the left side or the right side. But here's something that you want to keep in mind. The entire right side is one term. Remember, terms are separated by plus and minus signs. There's no plus or minus sign right here in the middle. So this is an entire term. But this is two terms. So let's see if we can combine these two terms together to make it into one term and somehow work with that one term to make it into that. We'll work with the left side here. Now, one thing to remember also is that, say you work with the left side and you see that, oh my goodness, this is becoming messy. It doesn't look like it's going to work. Well, then just use your eraser and maybe try the right side. Try to work with the right side. That's something you can always do. Let's go ahead, though, work with that left side. Tan, I'm going to make into sine over cosine. Cotangent into cosine over sine. Right side stays the same. Next, we want to make this into one term, and because of the addition sign here, could we cancel the cosines? Hopefully you said no. You can only cancel if you are multiplying. Same thing here, you can't cancel the signs. Because we are adding, though, what do we need to convert these to combine together? We need to convert to a common denominator. Keep in mind, we talked about this in class, the only time you convert to a common denominator is if you are adding or subtracting fractions. And here we have rational expressions or trigonometric expressions that we're adding. So let's get that common denominator. I need a sign right here. So times sine. Basically, that sign comes over like that. And at the very end, I need a cosine. Let's go ahead and now work with the left side some more. We're going to keep the right side the same. Sine times sine is sine squared. Plus, we'll bring down the plus. Cosine times cosine is cosine squared. The denominator stays the same, so it'll be sine cosine. Next, what does sine squared plus cosine squared equal? Hopefully you said 1. That's right from our formula sheet as well. So we have 1 over sine times cosine. The other side stays the same. Let's go ahead and split this up now into two separate fractions. I'm going to write the numerator 1 as just 1 times 1 because that's the same thing. And now let's split this up into 1 over sine times 1 over cosine. Right side stays the same. Now, what gives me the right to do this? Well, I'm going to claim that when I go from here to here, I haven't changed anything. Let me prove that to you. In the numerator, 1 times 1 is just 1 times 1. In the denominator, sine times cosine is just sine times cosine. Nothing changed. But 1 over sine is cosecant. 1 over cosine is secant. And the right side is secant. Oops, forgot an X there. Cosecant. And anytime that it's a multiplication that's happening, we can switch the order with these factors. You can always switch the order if this would be what sign? Plus or a times. Those are the only two times you can switch the order. And so we get secant cosecant equals secant cosecant. and that checks. All right, ladies and gentlemen, I want you to give this last one here a try, the problem here on the right. So pause it, try it, and then we will finish things up by going through this one. Okay, let's go ahead. Oops, sorry about that. Let's take a look at our last one. And if we're looking at this problem right here, which side is more complicated? It's hard to decide, but one way to do this is just to go ahead and to realize that, hey, I got two terms here. I have only a single term here. And so let's work with the left side where we have two terms, and let's try to combine them. We're going to make cosecant into 1 over sine, like that. Now, we have this part as a fraction. And if we have a fraction somewhere, let's go ahead and convert into fractions, because we know fractions work well together. Let's take this sine, we'll make it into sine over 1. And because this is a subtraction right here, could we cancel? Well, from the previous problem, you know you can only cancel if this is what? Multiply, right? So we won't cancel, but we'll convert to a common denominator. Because I have a sine right here, I'm going to go ahead and convert this into a sine by multiplying by sine on the bottom, sine on the top. And so now we're going to end up here getting 1 over sine minus, this will be sine times sine, which is sine squared over sine. Right side stays the same. Now we can write this over a common denominator, 1 minus sine squared. Denominator stays the same. Now I'm going to convert this. Just write this out. When we take a look, now our denominators are the same. All we need to do is focus on the numerators. Well, does 1 minus sine squared equal cosine squared? You bet it does. That's just rearranging an identity. So we have cosine squared on the left side. And that equals, oops, sorry about that, cosine squared over sine x on the right side. It checks. All right, ladies and gentlemen, now you're ready for the homework. Do your best.